Alright, so today we're working with division of polynomials. We're going to do long division, we're also going to do synthetic division and look at some uses of them. So to divide polynomials, a couple key things. Write them in descending order, biggest power to smallest order, okay? Or biggest power to smallest power. And then if you see any placeholders, okay, anything missing, like there's not an x squared term, there's not an x or something, then you insert placeholders. I like to just write zeros in there to remind me, otherwise things are not going to line up, it's not going to work correctly, okay? So I'd encourage you to take notes here as you watch this. You've got a good example in front of you. It's really going to help you in the lesson. So divide this big thing, okay, by x minus 3. Let me show you how I'd set that up. So x minus 3 divided into 2x cubed minus 5x squared plus, whoops, let me erase that real quick, plus x minus 8. Double check. Okay, I think I got that right. So we're going to go back to long division way back in our elementary school days. So watch how I do this. So I'm going to do x into 2x cubed, or in other words, what's 2x cubed divided by x? Think about if I simplified that. Well, that would just be 2x squared, wouldn't it? Or in other words, x times 2x squared would equal 2x cubed. So it's going to be 2x squared. Now watch the next step. Multiply this times this whole thing, and we're going to write them underneath. So 2x squared times x, 2x cubed, 2x squared times negative 3 is negative 6x squared. And now key step, we subtract. I like to go through and change those signs. So these ones go away. Negative 5x squared plus 6x squared, that is 1x squared. And bring down the next thing. Now you do it again. X into x squared, or basically x times what would give me x squared? Well, that is x. And now same thing, multiply this through this, so we're going to write it underneath. X times x is x squared. X times negative 3 is minus 3x. And subtract, I like to go through and change those. First term's always going to go away. X plus 3x is 4x. Bring down that minus 8. And do it one more time. X into 4x, or x times what is 4x? Of course, that's 4. Multiply it through 4x minus 12. And subtract. Goes away. Negative 8 plus 12 is 4. So didn't divide evenly, so we've got all this thing. And then we could say at the end, oh, remainder 4. So we had 4 left over. Okay. Now something key we're going to see as we move forward, if we get a remainder 0, that means this divided perfectly into it, and it's a factor of that polynomial. So that's something we'll see pop up. Okay. Let's talk synthetic division. Honestly, a little bit silly some of the things they do in this lesson, because you could use synthetic division for every one of the problems they give you, but they're trying to show you both ways. Now I already kind of showed here, and I just repeated this, to divide polynomials. Synthetic division is the same. You've got to have the same criteria, I guess. Okay. Now you can do synthetic division if the thing you're dividing looks like this. Okay, x minus 3, x plus 2, something like that nice linear factor coefficient of 1 in front. This is the same problem from the previous. Let me show you how I'd set it up though. So you take this number here and just do its opposite sign. So I'm going to do positive 3, and then I think they maybe write it a little different. I like to write it like this. And then I just take these coefficients and write them in here. Now I'm not missing anything, so I don't need any zeros. So I just write them 2. Give yourself a little space, space them out. I'm not writing the x's. Okay? And now, always bring this first number down. Just drop it down. We're going to multiply and bring this up here. 3 times 2 is 6. So just kind of watch the pattern. Okay, you'll get a feel for it. Add. So that's 1. Now do it again. Multiply. Bring it up. 3 times 1 is 3. Add. Do it again. Multiply. Bring it up. Now you're sitting there maybe saying, well, what in the world is he doing? Okay, again, watch it. Maybe rewind it. Look for the pattern. Negative 8 plus 12 is 4. Now let's see what we just did. We started with a cube. We divided an x out. So all of these are 1 less power than we started with. So I get 2x squared plus x plus 4 and this is my remainder, and I had 4 left over. Okay, now if I go back real quick, 2x squared plus x plus 4, remainder 4. Notice, exact same thing, okay? This is just a shorthand way to do it. It's pretty cool. And honestly, I use synthetic division a lot more than long division. There are a couple places you get into some higher math where you have to do the long division. Most of the time we can use synthetic division though. Okay, let's look at a couple applications. Now I already mentioned this. You divide polynomials with either long division or synthetic. If your remainder is 0, then the divisor, that thing you divided in, is a factor. Okay, so they say, hey, determine, is x minus 3 a factor of this big thing? Well, let's just divide it in with synthetic division real quick. In the lesson, let's see, I'll just do 3. Remember, change the sign. The lesson, they actually show you this before. They want you to do this before they show you synthetic division, so they make you do long division with it. I would just use synthetic division, personally. Okay, so remember the pattern? Bring that 1 down, multiply, add, multiply, add, multiply, add. Well, is that a factor? No, I got a remainder 60. Okay, I'd have to get remainder 0 for it to be a factor. So this is a big no there. Okay, that's how you check. If you get remainder 0, it's a factor. If you get a number here, it is not. Now, how about this one? Use synthetic division to completely factor this. So they're telling us it factors, and they give us something to start with. So I'm going to factor this out and then see what happens. So let's divide a 4 out. Again, I'm going to use synthetic division just because it's quicker. Now this is a good example. I want to point something out. Notice there's no x squared term, so it's like there's a 0x squared there. So I'm going to put a 0 in as a placeholder. Then my negative 37, and then my 84. Okay, remember what we do? Bring this down, multiply, bring it up, add, multiply, add these together, right? Negative 37 plus 16, that looks like negative 21. Multiply, negative 84, add. Hey, look at that. Remainder of 0. It's a factor, okay? So yeah, they gave us one. But here's what I'm interested in. This means x squared plus 4x minus 21. So basically, here's where we're at. We've got x minus 4. We just factored out of that thing. Here's what's left, so we just need to factor this. Well, factors of negative 21, so two numbers that multiply to make this, that add to make 4. Can you figure out what they are? 7 and negative 3 will work, won't they? So how about x plus 7 and x minus 3? Hey, we just completely factored that polynomial. Okay, one last thing I want to show for this one. The remainder theorem, and this isn't a big deal. You don't need to like remember this or anything, but it's kind of a cool application. If you've got some polynomial degrees bigger than 1, so quadratic, cubic, something like that, you divide it by something like this, nice linear term, basically use synthetic division, then the remainder is the same as evaluating the function. Okay, so let me show you what I mean. Use synthetic division to find p of a when a equals negative 3. So they basically say, hey, what's p of negative 3? Well, we've done that before. That just means go plug negative 3 in for x. That wouldn't be very hard to find, by the way. Okay, in fact, let's just do that real quick. So that would be negative 3 squared minus 7 times negative 3 minus 10. So that would be 9 plus 21 minus 10. So that's 30 minus 10. Hey, we get 20. Okay, now you already know how to do that. Let me show you how synthetic division is a way you could do that as well. So we're going to do negative 3 into this thing. 1, negative 7, negative 10. Bring your 1 down. Do you remember the process? Multiply, bring it up, add, multiply. Negative 3 times negative 10 is 30. Add 20. Hey, there's my remainder. Look how quick that was. 20. Same thing as evaluating the function. So that's just a cool little application. Remember, remainder is 0. It was a factor. If the remainder is not 0, then you just evaluated that function, basically. That's pretty cool. Okay, so I hope this helps you as you go through the lesson. Take good notes, practice things on paper, and I hope you have a good lesson.